Well, good afternoon, everyone. Thank you so much for joining us for the Command It October webinar. Can't believe it's already October. As we begin, I'm sure we'll have more people joining, but we do want to go ahead and start, and we are recording this webinar, and it will be posted on our Command It website. I have the honor of introducing Dr. Battle today. She's going to be our presenter today for exploring undergraduate research. And I would like to tell you a little about her. Dr. Battle is the Robert E. Denning Endowed Associate Professor in Computer Science and Engineering at the University of Washington. She is the co-director of the UW Interactive Data Lab and an active member of the UW Database Group. Her research interests focus on developing interactive data-intensive systems that can aid analysts in performing complex data exploration and analysis. Professor Battle was named one of the 35 innovators under 35 by the MIT Technology Review in 2020 and was selected as a Sloan Fellow in 2023. Her research has been supported by several organizations, including Adobe, VMware, Google, MotherDuck, and ORAU, the National Science Foundation, as well as the National Science Foundation. She holds an MS and a PhD in computer science from MIT and a BS in computer engineering from the University of Washington. And with that, I would like to give the floor to Dr. Battle. Thank you so much for being here today.
Thank you. It's a pleasure to be here. So my presentation today is going to be about exploring undergraduate research. The focus is on supporting undergraduate students. So when I'm talking, I'm going to kind of be directing towards that audience, but I think it's also useful information for faculty and staff and other folks who are interested in supporting and advancing undergraduate research opportunities. So, so I won't go into all my titles and stuff since we just went into that intro about me, but I will say a little bit more about my research and also just on the personal side. So my research spans multiple areas of computer science, including visualization, human-computer interaction, and data management and data science. And in particular, I love to study and model and understand people's behaviors when interacting with data, different kinds of data tools. That could be programming tools, querying tools, visualization, and more kind of design-oriented tools. And in all those scenarios, the idea is that people's behavior shouldn't be modified to fit the tools. The tools should be modified to fit their behavior. So all of the research I do is in that direction. And I call that behavior-driven optimization of data science tools. So beyond my research, I love to do lots of stuff hobbies-wise. And I mention these just to show that, faculty are not robots doing only research and teaching every day. We have other things we like to do too. So probably my biggest hobby is disc golf. I love, I guess you could also think of it as frisbee golf, but I am obsessed with that sport. I love being outside, and that sport allows me to do that. I also love to read. I've loved reading my entire life. And I like to do other things too, like cooking and playing board games and video games and traveling. I feel like at this point, I've done so many coast to coast moves that if anyone wants advice, I probably could give advice on that too. But just to talk a little bit about my academic journey, because I certainly wasn't born a professor. I did my bachelor's degree at the University of Washington. I went straight to grad school after that and got my master's and PhD at MIT. Then I actually went back to UW for a year to do a postdoctoral research position in the Interactive Data Lab, which I now co-direct as a faculty member, which to me always still feels pretty wild to run a lab that I was once a postdoc in. Then I went to the University of Maryland for 3 years in their computer science department as an assistant professor, and then I came back to the University of Washington. And I mention all these to also show that the academic journey is not necessarily this perfect linear path from student straight to professor. I see a hand from Tom Hurst. Hey, Tom. Tom was my colleague back when I was at Maryland. Um,
Did you have a question, Tom, or were you just saying hi?
Sorry, I meant to hit an emoji. Apologies for the interruption.
No problem.
yeah,
Thank you.
shout out. Yay, go Terps. I enjoyed my time at Maryland as well, even though I'm currently at UW. So yeah, I've had this kind of roundabout path to where I am now, but I think that's kind of what academia is like. And I just wanted to share that as well. So a lot of the material I'll cover today is centered around these four different questions about getting into research as an undergraduate student. So the first is, what is research? And the second is, how does research look across different subfields or areas of computing? And then I'll talk a little bit about motivation for doing undergraduate research, and then how to get into and succeed in undergraduate research. So first, what does it really mean to do research, or what is research? So if we talk about it in dictionary terms and we look it up in a dictionary, we see that research is a detailed study of a subject in order to discover new information or achieve a new understanding of it. And the way I like to think about this is what processes and communities do we build in science to make research happen? So, for example, a really important part of our process in doing research is applying the scientific method to identify and understand a phenomenon in the world, to collect data about it, conduct experiments to collect that data, and then to test our own understanding, our own hypotheses about that phenomenon. So it's not just the outcomes of research, but the process itself that helps to define what research is. And then a lot of different people are involved in research, not just faculty. So that could be research scientists, that could be lab technicians, staff members, postdoctoral researchers, and of course, graduate and undergraduate students. And research is not, controlled and owned purely by universities. It can happen, honestly, almost anywhere, but it happens most often at universities, but also in government labs and industry labs. Um, and I guess, so we talk a lot about the scientific method, and one way of sharing our work with the world is through academic publications, but I think there's also an important public-facing side to research as well. So, for example, advertising are, in the case of the University of Washington, computer science and engineering, advertising what we do and writing articles about it that are more accessible to the public. Um, so it's not just about doing research, but also communicating it. So in introducing myself, I talked about different areas of computer science, data visualization, human-computer interaction, data management. As it turns out, there are different communities that love to do that kind of work and center their research on that subfield or that area. And they operate differently. They have different conferences they like to publish their research in. So the way you do computer science research can vary a bit depending on the subfields that you're talking about. So in understanding what computer science research is, it's helpful to start with, well, what is what is science, and then what is computer science? So with science, we talked about it as a process of systematically building and advancing knowledge, and doing that through explaining and predicting phenomena in the real world. And as I mentioned, a big component of this is applying the scientific method, which follows some consistent steps. So I remember first learning about the scientific method in middle school, actually. And I remember thinking, do scientists actually do this? Is it really this formulaic? Um, and now I always chuckle when I think about it, because in a lot of ways, yes. But to me, the answer is yes and no. It's an important part of what we do, but as we encounter new challenges and new research problems, we have to adapt the scientific method to match what we want to learn or what phenomena we want to observe. But I like it because it represents our constant striving to objectively study what it is that we want to learn. Objectivity is critical in science. So of course, human beings, we're not naturally objective. There's a lot of subjectivity that can leak into everything that we do because we're human beings. But, as much as possible, we want to be systematic and objective in the work that we do when it comes to science. So we've talked about science. Now, what if we take the word computer and put it in front of it? What about computer science? Is that still science? So with computer science, there's science within it, but not all computer science is science. Similar to, say, maybe engineering disciplines, there's science within engineering, but engineering itself is not always research. It's not always science. So with science, we're forming hypotheses and then we're testing them using the scientific method. Uh, Revisiting this example of engineering, it's a lot about designing and implementation and problem solving. So you might apply what we learn from science to do that problem solving, but it's not always in itself science or research. And then we also use mathematics to support our work in computer science. And because of this, computer science is not always its own kind of siloed field. It often connects with other disciplines in a lot of interesting ways. And there are a lot of opportunities to answer important societal questions, environmental questions even, using computer science in conjunction with other disciplines. So in terms of subfields, I won't list them all, but I'll just talk about a few just to show how diverse computer science can be intellectually. So there are kind of classical areas that people might think about, such as, computer security or computer privacy. There could be systems engineering. There's core work at the center, building systems, AI, developing theory, developing proofs, creating programming languages. And then you can imagine using the core, you can build outward to have more and more societal impact in different areas. So I mentioned, security and privacy. That could help with things like energy and sustainability. It could help with accessibility. So how do we make technology benefit everybody, especially in people with disabilities? And you can imagine things even farther out, like neural engineering. So how do we intersect computing with the human brain, or not just humans, but with the brain, um, having impact in education and other areas as well. So you don't have to say purely in, AI or purely in programming language development to do computer science research. So within that, different subfields, because they can make they can have impact in such different spaces of, like humanity, society, the environment, they might need different kinds of methods to advance that research. Some areas rely on mathematical proofs, some and algorithm development, some rely more on systems building, a lot of coding. And then also the way that they evaluate their work can vary widely. Like you might build systematic benchmarks where you're writing software, maybe a lot of scripts to routinely test um, the innovations that are created. Or you could conduct what are called user studies or human subjects experiments, where you recruit people to interact with the software that you build to make sure that it actually benefits the target user group that you designed that software for. And then they also, because of this, will make different contributions in different areas of computer science. So if you do a lot of algorithmic work, then you're going to tend to contribute more new algorithms to our body of knowledge, or what scientists know about computer science. If you do a lot of user studies, then you might have a lot of deep insights on what people, how people experience the kinds of software that you build. And then within every area, we need to have an understanding of what scientists or what researchers have already done So that's where contributions like a literature review or survey of existing projects can be helpful and benefit respective communities. And also when someone's new to a community, a research community, say like an undergraduate student, reading those survey papers can be very helpful to help you gain your bearings without having had to read, say, hundreds of papers yourself. And then another thing I'll mention is that a lot of the things people chose to focus on in their community is driven in part by the culture of the community itself. So the community decides what they value, what they want to focus on. Through that is the methods that they choose to focus on and the contributions they choose to make. And I just want to highlight that. So with this in mind, the different areas of computer science, what research is and what it isn't, what might undergraduate research look like within this world? So you can imagine undergraduate research maybe starting at an initial point and then evolving over time as an undergraduate student gets more experience. So maybe in the first phase, the student is a helper on an existing project. And if they're not very familiar with the area or the topic that they're asked to work on, then you might be making smaller contributions as part of that team until you develop your own experience and your own background on the project's material and focus. So once you've been working on a project for a while or a particular topic area, an undergraduate student will have more experience they can build on. So then they can be more involved in the research as part of that lab or that research group. So they can make larger or more critical contributions because they know more and they have more experience. They could maybe even help to train fellow undergraduate students to onboard them onto teams. I've had that happen a lot in our lab when undergraduate students work with me for, say, at least a year or even multiple years. And then also they can have more involvement in research decisions. So helping to guide the next steps of the research project itself. So rather than, say me or a mentor recommending the next step every time, students, as they get more experience, will be able to suggest steps themselves. And I can say, oh, that's a great idea. You should totally do X, Y, Z. And then ideally, the dream is eventually students become more and more independent and they can conceive and guide their own research projects. So then I'm in more of a supporting role rather than um, the main driver of a project. Whereas the undergraduate student goes from being along for the ride to being in the driver's seat of that project. So you might be wondering, okay, well, if I do a lot of undergraduate research and I really like it, what happens next when I'm not an undergrad anymore and I graduate? So just to talk a bit more about what this academic path might look like the path that I took, you might do some undergraduate research for a number of years. And then say you want to go to graduate school, you can get a PhD, which can range a lot in how long it takes. It could take 4 years, it could take 8 years. This can also be subfield specific. It took me 6 years to get my PhD as one example, but I've known people who've done it in 4, and I've known people who've done it in 8. So it's pretty unique to the individual and the subfield that they work in. So after that, you could, like I did, become an assistant professor and then start working through the promotional ladder, basically. I started as an assistant, then I became an associate. Hopefully, eventually, I'll become a full professor. I feel like I'm on track for that. So from undergrad to professor, that's what this path might look like. That being said, that's not the only track. I don't want to scare anyone if they think, oh, if I start doing research, I have to be a professor. Definitely not. Definitely not. So here's some alternatives. So from undergraduate research and doing a PhD, another opportunity, instead of becoming a professor in a university, is to become a researcher, say in an industry research lab or a government research lab. Another opportunity is instead of becoming a professor, you could do industry applied research. So that would be less academic. There's definitely a lot less of a focus on, say, publishing research articles at that point. But you could still get to apply all of the skills you learned and use all of the techniques you developed in applied research, just not for publishing papers. And another one that is not on this slide is that you could get a graduate degree, not necessarily a PhD, but then also become teaching faculty, where some institutions might require a PhD, others might not. So if you want to do a teaching track, the path is a little bit different. But research experience can be very helpful as well for teaching track. So examples of government and nonprofit research labs. So you might have heard of some prominent national labs like Los Alamos or Argonne National Labs. Another one, that's an example that I'm familiar with because they have a strong tie with the University of Washington, is the Allen Institute for AI, or AI2. And these are not even close to all the government labs out there. Another one that's in the state of Washington actually is the Pacific Northwest National Labs, so PNNL. So example of industry research labs. So prominent tech companies will often have a research lab or research groups within that organization. Examples are Microsoft, Google, their research teams at Meta as well, and NVIDIA. And there are many more than this as well, but they're not always well advertised. So building a network within the computer science community can help you to gain access to understanding where there are research teams within industry that you could potentially work with. Okay, so now let's talk a bit about why someone might want to do research. Because I talked about, say, becoming a government researcher or an industry researcher, becoming a professor, but why would someone want to do research in the first place? Like, why get on that long career track to begin with? Or even do research and not go into academia, because that's still really valuable. You can build skills and whatnot. So from the perspective of researchers, like, why do scientists go into this? Some big reasons that resonate with me include wanting to contribute to society in a meaningful way, wanting to advance the knowledge of humanity, right? To learn things that no one else has learned before, or to do things no one else has done before. You can do that in science. And as part of that, I love challenging myself. I love pushing myself. So being able to learn about myself in the process of learning new things is the kind of thing that excites me. Also, being able to exercise creativity and innovation to come up with and to solve challenging problems in computer science. And also, if someone wants to be a professor, then you kind of have to do research to become a professor on the tenure track. So there are more reasons than just this, right? As I mentioned, there are benefits to research beyond this because a lot of undergraduate students do research and do not become a professor. They choose not to go into industry positions because there are just a lot of opportunities in computer science. And being a professor is really only one. So what are the benefits to research beyond, becoming a professor? So one is just to try it and see, right? You won't know unless you try. So I think it's worth giving research a try, at least for like one term, to see, do you like it or not? Because if you fall in love with it, then you know. If you don't fall in love with it, you also know that too. And you can feel confident not asking what if, once you graduate. It opens doors for graduate school and PhD programs. If you haven't done research, joining a PhD program would be more difficult. It helps to enrich your undergraduate experience, so it'll allow you to learn things that you're not necessarily going to learn in the classroom. And if you're at a top research institution, it's an opportunity to take advantage of something that your university is known for and really good at. There are a lot of paid opportunities in research, so in doing research, you can have a chance at getting one of those paid jobs. And something I think is really important about research is it teaches you how to learn about problems. Like what problems are out there, what problems have been solved, what problems haven't been solved, and what tools are available to solve those problems. And those kinds of skills are useful everywhere, not just research. You can apply them in industry and in entrepreneurship in figuring out, where's an area where I could start a new business or develop a new product that doesn't exist yet. And then other reasons, making money is not the same as having a positive impact on the world, not always. So in doing research, it allows you to explore both of those things or one of those things, depending on what you're more passionate about. And then it also allows you to dive deeper into topics in computer science that you might not get the opportunity to do through class. As an example, I teach a data visualization course at the University of Washington, and students are always asking me, is there going to be another like more advanced offering of the data viz course because they enjoy the material and they want to dive deeper. And unfortunately, I have to tell them, no, this is the only class we have. You could take the graduate version of the course. But students can still do a deep dive by participating in research projects in our lab. So that is one opportunity where students can still do that. Okay, so the rest of the time, I'm going to focus on talking about how to get into undergraduate research and how to succeed in undergraduate research, and then hopefully leave time for questions. Also, if there are any questions now, I'm happy to answer a couple questions.
Not seeing any in the chat at this time.
Okay, sounds good. All right, so how do we get into undergraduate research? So there are different types of research opportunities depending on the time of year and what you have time for. So probably the most common is doing research during the school year alongside classes. Another common one is doing a summer research experience. You can do research for course credit. You could do it as volunteer work. You could do it for pay. I encourage you to do research where it's going to directly benefit you, your learning, and what you need at that point in your undergraduate journey. So whether it's a paid position or for credit or for volunteering, just make sure it serves you and is getting you what you need. And you can work on projects that are shorter term or longer term. In my view, the more impactful projects tend to be longer term. So being able to contribute to a longer term project would be ideal. But again, based on what you can fit in your schedule and what you need, that might vary. And then, of course, there are many institutions all over the world, not just in the United States, where excellent research is being conducted. So you could do research at your home institution, and you could do research elsewhere. That could be in the country, that could be outside the country. And I've seen opportunities everywhere. So there's that. And limited opportunities in industry as well. There are some opportunities to do research as an undergraduate student in industry. I'll talk about that a tiny bit. So if you've not yet done research, there are some opportunities to get you started before you go out looking for opportunities, say programs or research labs to support you. You could look for a class that will give you basic skills in what you need to know to conduct research successfully. So one example is we have an undergraduate research series in the UW Allen School. CSE 390R is the first class in that sequence where we teach students skills like how to read a paper, how to find papers, how to present research, things like that. And then other universities offer this program, these kinds of things as well, like Stanford and UCSD. And then there are also online programs that, well, not a lot, but one prominent one I would like to highlight is the UR to PhD program that I think is an excellent alternative if your university does not have this opportunity. So there are research methods courses, often graduate level courses that you can take as well if you want to learn more advanced research methods or foundational research methods as well. So I would take a look at those. They might be offered at your university. You can learn a lot from reading research papers, even without having done any research yet. It might feel a little overwhelming at first, but that's how it is for everybody, actually. Because I've read at this point hundreds of scientific articles, I've gained a lot of experience in doing that, so I feel a lot more comfortable doing it. But in the very beginning, it did not feel comfortable at all. I felt like I knew absolutely nothing. And that's a muscle you can build early without having done even a day of research. A more accessible or more approachable way of doing this is to going to research talks. Because so researchers, they want to make sure all the technical details are in their article. So if someone wants to replicate their process, they can do it. In a talk, it's meant more to be easy for an audience to understand in a limited period of time. So going to talks can be a more approachable way of doing this rather than reading papers. So in terms of finding opportunities in the beginning, I would definitely look around in your department, maybe looking at websites online for different research labs and faculty members to see what kind of research they're doing and if there might be opportunities. And then also look at the university as a whole, because as it turns out, there's a lot of research that intersects with computing, but is not necessarily in a computer science or computer engineering department. So I would say be open to doing research outside of computer science and engineering as well, in case that is of interest, especially for things like quantum computing. Quantum computing involves multiple disciplines, not just computer science. So I would keep an eye out for that. I'll give one example. So in the UW Allen School, we have a page of our website that is 100% about getting involved in undergraduate research and the various ways that we support that in our school. That could be for pay, for credit, in some limited cases for volunteer work, as long as it serves the student. So here on the slide, I'm showing examples of research labs actually advertising the opportunities available in the lab for undergraduate researchers and how undergraduate researchers should contact the lab to get involved. So I co-direct the interactive data lab, and our process is that we have a Google form that we ask students to fill out. And if they want to email us, we have a dedicated mailing list that we've set up where students can email that mailing list, letting us know that they applied and what opportunities they're interested in, what they're excited about. So I would say, see if there's a page under the department or at the university about undergraduate research opportunities, and then go through those details to understand how you could potentially reach out to labs if it's available. And another opportunity at our university, the University of Washington, as another example, is that we have an office supporting undergraduate research on campus, and they have a lot of links and resources for finding opportunities to do undergraduate research. And they even have a database of opportunities that faculty and grad students and I think researchers can post there. And then undergraduate students can search the database for opportunities as well. So another option that I think is viable, I don't think it's as easy as finding structured opportunities that your department or campus already have available. But another option is to just email researchers directly and seeing if their lab has opportunities. So that could be faculty, that could be graduate students in the lab. And I'll just give a few tips if you want to, say, cold email people about potential research opportunities, because I've had this happen to me a lot in the past, and sometimes it works, sometimes it doesn't, and there are things you can do to make it more effective. So one is, if you know of some labs already that you're excited about and you would love an opportunity to work with them, sorry, not for them, with them, do your homework. Look up what the lab does. Look at their recently published papers. Get as a good of an understanding as you can. And you can time box it, right? You don't have to spend a lot of time doing this. But learn as much as you can about the lab on your own before you reach out to anybody. And treat it like you're trying to get a job. Because in reality, if that lab is really exciting and they're doing research that everyone thinks is really cool, probably lots of people are reaching out to them. So you have to kind of advocate for yourself. Why should they respond to your email versus the other emails they're getting from other undergraduate students? So that's how I would think about it. And it's a lot like trying to find a job or trying to find an internship. You've got to find ways to make yourself stand out a little bit. And it doesn't have to be really hard. And I think there's some tricks to it. So part is faculty get a lot of emails, including emails about participating in their labs. So one way to make this more approachable and go a little bit faster is to see if you can get contact information for graduate students in the lab. Because emailing graduate students, they're oftentimes it's graduate students who are leading the projects, not the faculty necessarily. The faculty act as mentors, and the graduate students drive their own projects a lot of the time. So if you contact a graduate student, that's almost direct access to specific projects that the lab's working on. And then also making it really easy to meet with them. So being flexible, maybe offering in advance some potential meeting times, things like that. And then also, if you email them and you don't hear back from them, that's okay. That's extremely common. Just email them again in a week. Maybe don't email them every day. You don't want them to become exasperated, but if you don't hear back in a week, definitely feel free to email them again. I forget emails all the time. So if someone doesn't email me again, I might never remember to reply. So I'll just give a quick example here. I'm not going to share this because I want you to read this slide, but just like, for example, in the recording, if you want to go back and see things that I highlighted, you can. But the idea here is to have a concrete example of an email that I think could work. And here, I'll just highlight a couple of things. So the first is that the email isn't starting with, can I please work in your lab? Because the ask to pique someone's interest shouldn't be about you, it should be about them. So, and the best way to do that with researchers is to ask them about their research, because that will catch their attention more than, hey, can I work in your lab? And then from that, shifting to what you're thinking about their research. So not just your research is cool, but I think this aspect of your research is cool. Can I learn more about this thing? Because then you're starting to contribute more of your thinking and not just complementing their work. And then towards the end is where you start to get to the ask. And even there, you want to not just say, can I get in your lab, but these are the skills I have, and this is why I think these skills will benefit your lab. And then doing your homework on if, for example, they've already posted recruiting information for getting involved as an undergraduate researcher, explaining that you've looked at it and that you've gone through that process can be a benefit. If they don't have it, you can mention, oh, I looked online. I couldn't find instructions for how to reach out to the lab. So I'm emailing you. So those things can help with cold emails to researchers. So just to summarize, look in your department at your university for opportunities. Try to get on mailing lists as well, or any discussion boards that if they're geared towards research. So one example we have is that we have an ed discussion board for undergraduate students with a research category. So students can use ed discussion to learn about research opportunities in our school. So not just from our website. Okay, so the last thing I'm going to talk about is summer opportunities. And summer opportunities tend to be paid positions. So I'm going to treat them a little differently from the previous ones because the previous ones may or may not be a paid opportunity. And I'm going to preface this with, for international students, it's a tough situation because a lot of university summer programs are funded, for example, by the federal government. And the federal government has really strict guidelines on who can and cannot be paid by those grants. Lots of times you have to be a US citizen or permanent resident to be paid by the grants that fund those kinds of programs. So that means there's a lot fewer opportunities for international students, but not zero. For example, a faculty member, if they have grants, those grants might be able to pay for an international student. So even if you can't be paid directly by a certain ORAU program, if a faculty member participates in that program, they could potentially pay for your participation. So it's worth looking at the programs anyway, even for international students, and to see if there are workarounds to help you. And then also things like fellowships, or maybe industrial or international programs. So programs that are not tied to just the US federal government could be of benefit. So with summer research programs, they're treated a lot like an industry internship, and they tend to be pretty structured. There are a lot of them. So I think it's worth searching everywhere you can think of online for potential research opportunities. Applications, they could start as early as like nowish in the next couple months, and they go all through December, January, and February even. Typically, you need to have at least one recommendation letter for the programs. But you do not necessarily have to have research experience. And depending on the program, that could be a benefit. That could also be a detriment to your application. So for example, if the program is meant for students who don't have much research experience, or if they want a mix of people who do and don't have research experience, then it's really not a problem if you don't have any research experience. There are other programs that are more competitive where it will be a lot harder to get into the program if you don't have research experience. So I would say for whatever programs you're looking at, read their materials, their website, and make sure you understand the expectations and the requirements for getting into research, getting into their programs. So I'll talk just for sake of time. I'm going to focus on the ORAU program because I am currently a co-director of the ORAU program at the University of Washington, which is a research experience for undergraduates or REU program, specifically focused on human-centered computing, broadly defined. And DUB stands for Design, Use, Build. It's a grassroots collective of researchers and practitioners and supporters at the University of Washington or affiliated with the University of Washington. But I also want to highlight the DREW program as well, which is a great opportunity for students to connect with faculty for research opportunities, not at your home institution. So the ORAU, you apply, like our applications will open towards the end of this year, for example. So this is 2025 in the image. We will have it for 2026 as well, and our applications will open towards the end of the year. Typically, the deadline is at the end of January or very beginning of February. And then we review applications, we interview applicants, and then we select our cohort for the next year. And our cohort is usually around 10 students, but since we recently became an RU site, we were hoping to have it be around, the target was originally around 20 students each summer. So the WRU is an example of an NSF-funded RU site. There are actually many of them all over the country. And one way that you can find and apply for NSF-funded RU programs is through their portal called ETAP. And there's a link here, etap.nsf.gov. I would definitely go there to search for summer research opportunities because a lot of them get posted there. And ETAP makes it pretty easy to submit applications to multiple programs. And one thing that's nice with ETAP as well is that you can search for opportunities. You can filter by, say, different fields. You can look at them according to due dates and things like that. So ETAP is a great resource for looking up and trying to apply for opportunities. Another way is just doing a plain online search, for example, like a Google search. And then if you want to do research in, say, human-computer interaction or software engineering or anything like that, you can see if there are research programs under those subfields or those topics through search engines. And you can use a lot of different keywords because they might use different language to explain that program. Like UROP is a common acronym, not just ORAU. And UROP stands for Undergraduate Research Opportunity Program, where there could be a summer institute or summer this or that. So I would say definitely search around and see what you can find. Don't just look at UTAP. Don't just look for RU. Don't just look for CSE. Be flexible in what you look for. And I would say even though we call them all RUs and we have to give them a name, lots of times the research that happens under that RU can be more flexible than it sounds. So I'll give one example for mailing lists. I'm not putting this here because you should register for this mailing list, but uh, at in the Allen School, we have a mailing list called ugrad-researchers at CS, which allows undergraduate researchers to learn about opportunities that we find that we post to the mailing list, kind of like the discussion board I mentioned earlier. So that's I would think of that as an example. So very briefly, other opportunities. So another opportunity is to reach out to research labs and see if they would support a student for the summer. This is a great way of getting into paid research over the summer as an international student, since some of these NSF-funded programs might not be able to support international students. Other opportunities include industry or government labs. So, for example, I mentioned the Allen Institute for AI, AI2. They have research internships that students can apply for. Microsoft also has undergraduate research internships that you can apply for, and NASA does as well, NASA JPL. And the Department of Energy National Labs has a program that you can apply for to do undergraduate work. And they're international programs as well. And there are quite a few of them. I think there's one in Japan as well that I've written letters of recommendation for. So I would just say search online. Just to say a bit more about the DOE ones. So what's cool about the DOE ones is they have a really long list of potential participating labs. So when you apply, you could have some flexibility as far as not flexibility, but it could be exciting where you end up working because there are labs all over the country. And then the deadlines for summer 2026, the deadline's in January. So I'm just mentioning it now in case anyone's interested so they could prepare to apply. All right, so with applying to RU programs, I would take it pretty seriously. I would want to prepare in advance, and I would think of it almost like practice for applying to graduate school. I don't want to scare anybody, but if you successfully apply to an RU program, then you get a taste of what it's like to apply to a PhD program. But you're going to want a resume or a curriculum vitae or your CV. You're going to want a transcript, definitely a letter of recommendation. Oftentimes, you're going to have to write a statement of interest. So, why are you interested in that program and why should they select you for their summer cohort? That's usually what the purpose of the statement is. And then you might have to respond to specific prompts that they give you as part of the application. So, here's an example from the Robotics Institute Summer Scholars Program. Here they have on their website specific information that students should look into for applying to the program. This is an old snapshot from the WRU website. We've since revamped it. I apologize for not updating that slide, but we have specific information that we give out to students about the program. We list out all the expectations of a program in a Google Doc that's available for anyone to view. And in our application, we have specific prompts that we ask students to fill out as part of the application. So for a letter of recommendation, ideally, you want the letter writer to be able to speak to your skills that would benefit you as a researcher. So that doesn't mean that you have to have a research advisor or research mentor write you the letter, but you want that person to be able to speak to the kinds of skills that you're going to need to succeed as a researcher. So examples could be curiosity and inquisitiveness. It could be, your motivation or your ability to work independently. It could be, resourcefulness, your critical thinking skills, your perseverance, communication skills, especially things like technical communication or writing skills. Any and all of those are valuable for someone to speak to in a recommendation letter. And it doesn't have to be a professor. Ideally, someone who's supervised you on a project for an extended period of time, because research takes an extended period of time. So not someone that you've worked with for like 2 weeks. Ideally, someone you've worked with for at least a full term. Ideally, but it doesn't have to be a full term. There could be constraints depending on when in the school year the opportunity is. And you wanna ask as far ahead as possible. One example for me is a rule I give to students who ask me for letters is if they don't give me at least 2 weeks advance notice, I usually say no. So I would keep that in mind too in requesting letters. So I already talked about statements, so I don't think I'm gonna go through this slide. On the left-hand side is an example of prompts that we use for the ORAU program. So how do you feel about reminders regarding recommendation requests? I would say if a week's gone by and you haven't heard anything, you can feel free to email them. If it's close to the deadline and you just want to make sure, you want to double check they've submitted the letter, you should feel free to email them. Email them in advance of weekends. Do not email them about something on the weekend. I had a student who emailed me about something urgent around letters happening on the weekend, but I prefer not to have to check email on the weekend. So we ended up having to miss that deadline because I thought I had correctly submitted the letter. Something happened on the application portal side. I had to submit it again. I think it's going to be fine, but you want to do things in advance of weekends so that no one's getting stressed out. Yeah, these are examples of attributes that are helpful in succeeding in research, and you can think of it also to support your summer research applications, where I would say eventually becoming an independent researcher is ideal, being able to exercise your creativity and critical thinking skills is ideal, and probably, in my opinion, the most important skill is resilience and perseverance. So your ability to kind of stick with something when it gets hard and see it through to the end. You need that to get a PhD. So that to me is like a cornerstone of research. And then in the last minute or so here, I'll just mention in conducting research and wanting to be successful with it, it's helpful to kind of break it down and think about it in terms of steps. And in research, the steps are really formulating the problem that we want to solve. A lot of the work we do just goes into saying, well, what exactly even is the problem here? Because once the problem is clearly defined, you can start to break it down and come up with solutions or steps that we can follow to work toward the solution. And in the beginning, undergraduate students will only really be able to reason about and contribute to smaller scale problems. But as you develop more experience and a deeper understanding of the topic area or the subfield that you work in, you can start to think about bigger and bigger problems and make larger contributions and develop broader solutions. So maybe in the beginning, it's helping to like read papers, helping to debug a specific part of a larger code base, maybe helping to come up with a website design for a new project idea. In the beginning, things of smaller scope. And then later you can work towards larger things like helping to envision a larger scale system to tackle a bigger problem. And then you might be able to break this down into certain skills that you need to achieve that smaller problem. For example, being able to ask good questions, be able to manage your time well, things like that. And then with a larger scale, you can start to be working towards these larger contributions, which are kinds become publishable units within academic articles. And that might require different kinds of skills. For example, if you're going to design your own user study and not just contribute to a user study, that's going to require experiment design skills. If you want to publish a mathematical proof, you have to be able to have the skills to operate at that level to publish, say, like a theory paper. Okay, so that's it for all of the slides. And we have a few more minutes for questions, I think.
Yes, we do. If anybody would like to come on camera, you're welcome to raise your hand. You're welcome to ask Dr. Battle any specific questions. I had a question from the earlier part of your presentation when you talked about there being two tracks and you don't have to choose to be a professor. Did you ever look back after going on that path towards professorship?
So in the beginning, as an undergraduate student, I felt like all options were on the table, and I wasn't necessarily thinking of being a professor in the beginning. I would say as I experienced more things like doing internships at like Microsoft and Intel and trying out research as an undergrad, I decided actually I want to go to grad school and I want to do research because of the things I've tried, I've enjoyed research the most. And then in graduate school, I was trying to keep all doors open as well. And by the time I graduated, I decided, okay, I would love to work at an ambitious industry research lab like Microsoft Research or become a professor. And then I ended up becoming a professor and then loving that. And then from time to time, I think it's always healthy to evaluate your options and understand, okay, what is going to serve me the best now? And I feel over my career so far, I've really enjoyed being a professor, and I don't necessarily see myself leaving academia. But if I wanted to start a company or something, I'd have to reevaluate that. So that's how I think about it.
You definitely seem to love what you do, and you seem like a professor I wouldn't mind having. Looks like we did get a few more questions in the last few minutes here. When did you start building your CV?
So the way I say CV is it's kind of like a fancy word for resume. And in academia, you just have to add a couple things um, and remove a couple things. So we don't care as much on CVs about like classes taken. We care more about what projects have you completed, um, what papers have you published, things like that. So from that perspective, if you already have a resume, you're kind of already starting to build your CV. And it's never too early to start, I would say.
Definitely. Looks like we also have a question from David. David, did you want to ask a question or were you just raising your hand?
I did want to ask a question. Is that okay?
Sure. We can't hear you very well, though.
Oh, I'm sorry. Is that any better? Well, no.
Okay, go for it. We'll help you.
Okay, thank you. So with at least like with what I envision my pathway would be, I'm more interested in working in industry, so it would be applied research. But I do know the instances with industry where if you do get a PhD, you're considered overqualified. So I was just wondering, how would you then go about strategically aligning your pathway in such a way where the work you're doing in the PhD is directly contributing to problems within industry?
So I have had a lot of collaborations with industry folks in the past, including industry researchers. I'd say if you want your PhD research to align with industry interests and needs, I would start early with building a network of talking to people in industry about the kinds of problems that they encounter. And then with your PhD, the skills that you bring in would be, okay, which of these industry problems are research and which of them are not, which is is quite powerful actually. Because for the ones that are not industry research, you don't want to focus your PhD on them because those projects shouldn't go in your dissertation. The things that are research problems and address an industry need, that is really exciting. And we actually do that a lot in database research. Well, in every subfield you can, but I see it happen the most of the areas I work in databases. And just to answer a question in the chat very quickly, whether a postdoc is required or not really depends on the subfield. I think the best thing to do is, if you can, maybe reach out to a professor in that subfield, asking them about what their career path was like and what the expectations are if someone wants to work in that area. And then industry versus academic research. The main differences are with academic research, it's harder to get funding because you have to write a bunch of grants and ask people to fund what you want to do. But once you get the funding, it's awesome because then you do what you want, and people already, like, by giving you the grant, they've already agreed that you should do it. With industry research, it's kind of the opposite. It's not hard to get money because you're attached to a company. The company already has money, but then what you do really has to align closely with the company's interests. As an example, AI has taken industry by storm, and a lot of industry researchers have to do AI-related research, whether they like it or not, because of that. A bunch of people really like it, but some people don't want all of their projects to have to be AI-related. So that's how I think about it.
It's great questions and great answers. We want to thank you so much, Dr. Battle, for this wonderful presentation. It was very informative, and as we stated, the recording will be available on our website. Thank you, everyone, and we hope you have a great afternoon.
Thanks, everyone.